Yes, welcome. Today we are going to be looking at Ohm's law. Who is playing music? Please off it. We are going to be looking at what? Ohm's law. Ohm's law is a very popular law in electricity. Is that clear? So we are going to be looking at the statement of Ohm's law. Ohm's law states that current passing through a wire. It states that what? The current passing through a wire. Let's say we have a wire that is connected to a what? Cell. Connected to a what? Cell. A wire is always, for current to move, there has to be a cell, isn't it? So, if this is the positive terminal of the cell and this is the negative terminal, you understand? Ohm's law is telling you that if this is a wire, that the current that is passing through this wire is directly proportional to the what? Potential difference between the ends of the what? Wire. Between the ends of the what? Wire. Let's say the potential difference between here and here. You understand? If the potential difference between here and here is very large, more current will do what? Pass. More current will do what? Flow. If the potential difference between the positive terminal and the negative side is low, lesser current will do what? Flow. So, the more the potential difference, the more the what? Current. Is that clear? That is the statement of what? Ohm's law. It says that the current passing through a wire is directly proportional to the potential what? Difference between the ends of the wire. Provided that the temperature of the wire remains what? Constant. The temperature of this wire must be equal to what? Constant. It must remain what? Constant. You understand? So the more the potential difference being supplied by the cell, the more current will flow. And like I told you that potential difference or EMF is the force or the energy that enables charges to flow in a circuit, is it not? So this law is simply telling us that the more the potential difference, PD, which is measured in what? Volts. The more the PD, the higher the potential difference, the higher the what? The higher the what? Current. Is that clear? And mathematically you can represent it as saying potential difference V is directly proportional to what? Current. The higher the potential difference, the higher the what? Current. This is how you represent direct proportion in mathematics. Is that clear? Now when V, potential difference is measured in what? Volts, is it not? And is presented by V. Is directly proportional to what? Current, I. Now, if you want to replace this direct proportional variability with equal to sign, you have to introduce a what? Constant. You have to introduce a what? Constant. K. So that you can now say that potential difference V is equal to what? Ki, constant I, which is current. Is that clear? Now, they are trying to tell us that the constant K is a measure of the what? Resistance. It's a measure of the what? Resistance. So you can replace this K with what? R. So that you can have V equal to what? IR. This is a very important equation of electricity. This is a very important what? Equation of electricity. And it is known as the equation of what? Ohm's law. It is known as the equation of what? Ohm's law. V equal to what? IR. So in subsequent classes, we are going to be doing calculation using what? V equal to what? IR. Did you see the way we arrived at V equal to IR? Can you see it? Yes. So it's very, very important. We are going to be using this equation. And this equation stems from the fact that the current passing through a wire is directly proportional to the what? Potential what? Difference between the ends. Provided that the temperature remains what? Constant. How can you verify Ohm's law? Verification of Ohm's law. How can you verify Ohm's law? You can verify it using what? Voltmeter, ammeter, what? Method. So when you have the voltage, you understand, and you have the ammeter reading. The ammeter measures the what? Current. Whereas the voltmeter measures the what? Potential difference. You understand? And it's telling us that As the voltage is increasing, the current is what? Increasing. As the voltage is increasing, the current is what? Increasing. As the voltage is increasing, the current is what? Increasing. So you're gonna have a straight line graph, isn't it? When you plot the slope, you get what? The slope will give us the what? Resistance. The slope will give us the what? Resistance. So if you plot this, you're going to verify Ohm's law. Now, what are the limitations of Ohm's law? What are the limitations? You see that in the statement, it says that temperature must be what? Temperature must be what? Constant. So there has to be constant wire temperature. Is that clear? The wire that you're checking for Ohm's law, the temperature must be what? Constant. There should be no tension on the wire. There should be no what? Tension on the wire. You don't need to apply load on this wire. Eh? You just have to keep it the way it is. And the wire must have uniform cross-sectional area. Is that clear? You cannot have a wire like this. And some places bigger and some places thinner. You understand? The wire has to be what? Uniform what? Cross-sectional area. So once you have all this, then you can have the wire to obey Ohm's law. Is that clear? What is Ohm's state? Who can state Ohm's law for me? Ohm's law states that what?
The electrical current passing through the metallic conductor at a constant temperature directly proportional to the potential difference.
Perfect. That is the statement of Ohm's law. The electric current passing through a wire is directly proportional to the what? Potential difference between each what? Ends, provided that the temperature remains what? Constant. And the Ohm's law equation is what? V equal to what? IR. V equal to what? IR. And you can verify Ohm's law by using the what? Voltmeter, ammeter what? Method. And for Ohm's law to be obeyed, there has to be constant wire temperature. There should be no tension on the wire. And there should be uniform cross-sectional area of the what? Wire. And also the wire must be made of the same material. The wire must be made of the same what? The wire material must be the what? The same. You cannot use a wire that part of it is copper and part of it is zinc or something. You understand? There has to be copper all through. Is that clear? So that's where we stop for Ohm's law. We're going to continue later. Thank you.